Hello, student. Welcome back to Mr. Lee Technology Channel. This is the part 2 of the water tower, and let's begin. So on the screen, you can see there's a line drawing that I intended to build for my water tower. So for each of the project that you're starting, you may always start with a very simple line sketch. As you can see, this water tower has the dimension of 210 mm tall, and it has approximately about 112 mm wide base. So let me just add in the dimension here. Just add in the dimension for the base. Oh, by the way, this is not a requirement for Year 7 student. All right, this application that I'm using is a Rhino 3D. You will only learn about it if you are taking the Year 9 and 10 Design Technology course. For now, you're all good. So this is a intended design of 210 mm tall, and then with a base of 120 mm wide. Water tower design. Let's just do this one. So here you can see, while all the dimension that is being put in place, right? This is just a concept. You cannot build your water tower based on this. And the reason is, if there's a need for you to build it, you may notice that there's a lot of consideration. For example, you can see the second horizontal beam. Just the design sketch line itself is about 100 mm. But if you put it into the frame with all the thickness, it will actually shrink to about 90.65. Let me change another view. So here you can see, while you're building a water tower, the radar pine sticks that given to you is about 5 millimeter thick. So you cannot just assume that based on the line drawing here, they will work. The calculation comes in that when you think about how each of the sticks is going to be cut and placed. So for example, here you can see that I have the top with one solid sticks across, and then another pieces put at the bottom. So I can have the diagonal sticks across the side, say we mean one pieces that I'm not going to cut it through. And you can see the middle pillars here is being separated into 3 different sections, while the horizontal beam remaining intact as one pieces. So for this particular design that I'm designing, it's meant to have a maximum center support and to reduce the tension on the side. I keep each of the level pieces remain one without cutting it. And if you're looking further down, you may notice that for different pieces, the cutting angle will be different. So for the first top level here, in order to make sure that it fits to the top and second beam, I need to cut it about 63.4 degree so that it will keep it flush. But the last one, actually, the angle is a bit lower, 55.3. So whenever you try to prepare the material and cut it, always consider, okay, to cut it nearer to the particular angle. And here you can see that with the original drawing itself, the bottom level diagonal beam is about 88.85. But when I have to consider the material angle and plus the total length, it's about 78.28. So make sure when you're doing the planning, while you're sketching an idea, the design itself have to be accurate so that you will not have a loss of misalignment or miscalculation. And that's all for the designing and planning stage. Let me turn into another view and have a look to show you even this come into a more three-dimensional shape. Let me just disable all this. All right, here you can see I have already extracted a wooden frame with thickness. But this is just one single panel. Remember, water tower need to have at least 3 to 4 sides. So once you build on the water tower side and you get all four ready, you may want to check the total height, the diagonal angle at the side, and also for the individual sticks if they have attached firmly and securely. And when you're done, you may want to just do a trowel assembly by placing them at the particular angle and see if it matches. So here you can see I'm just test out side by side without assembling them to see if they can be securely attached all together. And when it's done, I will there move it in further. So for a four-side water tower structure, I can paste it using the one-side alternate method. You can see here, each of the panel has one side sticking to the end of it and the other side sticking to the other end. So using alternate method allows you to combine all four panels together securely while you still have a flat bottom, the flat side foundation, and a flat top for the water tank. So once you have securely assembled them and have tested that the stability are good enough, we will then put the water tower tank on top to test if the whole structure are flat and stable enough. And once this test done, we will then allow you to put the water tower to the testing machines to test for the weight to strength ratio. And that's all. Hope that y'all will get a amazing result. Thanks for watching.